In today's math lesson, using the standard form, we're going to graph an equation. Remembering that the standard form of an equation is set up in the format of ax plus by equals c, we're going to use the 3 steps of finding our x and y intercepts, and we're going to see how to use those to graph our line. Let's start by reviewing those 3 steps of how to find intercepts. We learned in the previous lesson that the first step in finding an intercept is to cover the letter that you don't need. The second step is to rewrite your new tiny equation. Your third and final step is an if necessary. If necessary, solve that tiny equation by dividing. We're going to do our 3 steps for both the x-intercept and the y-intercept. Finally, you will plot and connect the 2 points, the 2 intercepts. Example 1. Graph this function using intercepts, where 7x minus 9y is equal to 63. Knowing that we have to find both the x-intercept and the y-intercept, it's just a smart move, a good idea to give yourselves organized space, lots of space, to find both of your needed intercepts. So let's start with our x-intercept. Step 1, cover the letter that you don't need. Well, if I'm solving for the x-intercept, then I don't need the y. And so we said in the steps, cover the letter you don't need, which you can just cover with your finger, or you can mark it out with your writing utensil, of course. And then step 2, rewrite your tiny equation. So if I got rid of my minus 9y, then my tiny equation is 7x equals 63. Our third step is the if necessary, solve by dividing. And it is necessary here, and we know that we have to solve because there's a 7 with our x. Divide both sides as instructed to solve for x. Our 7's cancel out, leaving us with an x-intercept of 63 divided by 7 being 9. Now that we have that, let's place that point on our coordinate plane. The x-axis is my horizontal axis. Now that it's labeled, we're going to go put our point on x equaling 9. All right, step 1, or intercept 1, completed. Let's go solve for the y-intercept. So we start the steps over. Cover the letter you don't need. Okay. If I'm solving for y, then I don't need the 7x, which means that I can either cover that with my finger or I can mark it out, and it leaves us with negative 9y equals 63. So I've now done step 1 and step 2. I have covered, I have rewritten, and then if necessary, solve. Yep, since I have a coefficient with my y, we do need to solve by dividing that negative 9 on both sides of the equation. As a result, y equals 63 divided by negative 9, which happens to make a negative 7. Thus, the y-intercept of our equation is negative 7. Let's plot that. Our y-axis is this vertical axis in the center of our coordinate plane, and our intercept is at y equaling negative 7. Okay, the introduction said to solve for both the x and the y-intercept. We've done that. And then it says plot and connect the 2 points. So I've plotted them both. We'll get out our handy dandy ruler and let's connect them. And there is the line graphed on your coordinate plane using your x and y intercepts. And there you go. Example 2. We're going to graph this function using intercepts where 2x minus 5y is equal to negative 20. Now that we have our paper organized and spaced out, let's see if we can find our first intercept. So for the x-intercept, we know that we need to cover the letter that we don't need. If I'm finding the x, then I don't need y. So I cover that up, or I just mark it out. Step 2, rewrite your tiny equation. So our tiny equation is 2x equals negative 20. Step 3, if necessary, solve by dividing. Okay, well, since I have a coefficient of 2, that means I definitely do need to divide off the 2, thus solving for x, where our x-intercept comes from negative 20 divided by 2, which creates a quotient of negative 10. All right, now we have our x-intercept. So here on my x-axis, we're looking for the coordinate point of the intercept being negative 10, which is all the way over here on the far left. Great. Now we can solve for the y-intercept. Starting over, cover the letter that you don't need. If I'm solving for y, then I don't need the x, which I can cover with my finger, or I can mark it out. Step 2, rewrite your tiny equation. That would be negative 5y equals negative 20. Make sure you do not lose the negative that's here on the 5. If you do, we've just changed the whole problem, which is not going to work in your benefit. Step 3, if necessary, solve for y by dividing. And it is necessary because I have a coefficient in front of my y. When I divide, that means I have negative 20 divided by negative 5. A negative divided by a negative is a positive. 20 divided by 5 is 4. All right, on my y vertical axis, now labeled, I'm looking for the intercept of 4, and here it is. Okay, now that I have found both the x and the y intercept, it is time to connect them and call this problem done. So here I am, handy dandy ruler, and we have connected our two intercepts. And there you go. Example 3. We're going to graph this function using its intercepts where 8x minus y is equal to 8. Let's start this process by solving for our x-intercept. We know that we need to cover up the letter, the variable that we don't need. Since I'm looking for the x, then I don't need the y. So we cover that up with our handy-dandy finger that God made for us, or we mark it out. And then step 2, we rewrite our tiny equation of 8x equals 8. Step 3, if necessary, divide. Okay, it is necessary because I had a coefficient in front of that x, and I have to get x all alone. So when I divide off the 8, 8 divided by 8 gives us an x-intercept of 1. Here on my coordinate plane, my x-axis, nice and horizontal through the middle of things, and the intercept is equal to 1. So I have now plotted my first intercept of the given problem. Okay, let's do the second half. Our y-intercept tells us that we don't need to use or look at our x term. So I can cover that up, or I can mark it out, which I choose to do. Thus leaving us with a minus or negative y equaling 8. If necessary, solve by dividing. Well, there's no number showing. Yeah, actually there is. Because there's a minus, there's a negative. That is an understood negative 1. And we are not allowed to call this process done until not only is that y alone without a number in front of it, but it's also positive. As a result, 8 divided by negative 1 is negative 8. And here with our y-axis being the vertical line through the center of our coordinate plane, our y-intercept is here towards the bottom at negative 8. Now that I have plotted both of my intercepts, let's get our handy-dandy ruler and connect them. If you're having to graph using standard form, it's really very friendly, very simple. I think it's actually probably easier, faster to do correctly than with the slope-intercept form, truth be told. And there you go. Example 4. We're going to graph this function using intercepts where 2x minus y is equal to 6. Alrighty, let's go solve for the x-intercept. Step 1, cover the variable you don't need. Got it. And I've also marked it out for good measure. Step 2, rewrite your tiny equation. 2x equals 6. Step 3, if necessary, solve by dividing, and it is necessary. There's a coefficient in front of that x, so we divide it out, and thus we are able to determine that our x-intercept, 6 divided by 2, is 3. On our coordinate plane, having found our x-axis being the horizontal axis in the center, our x-intercept is at the point 3. All right, that's plotted. Now let's go solve for the y-intercept. So we know with the y-intercept, I don't need my x term, so I can cover that up, or I can mark it out, which I choose to do. And now step 2, rewrite our tiny equation. Negative y equals 6. If necessary, solve for y. Yes, I definitely have to divide by a -1 because y has to be both alone and positive. We've got to get that y positive. As a result, the y-intercept coming from 6 divided by -1 is -6. With our y-axis here in the center vertical part of the coordinate plane, we place our point on the y-intercept of -6. There that is. Now that I've plotted both of my intercepts, let's get our handy-dandy ruler and connect them. And there you go. On our 5th and final example, we're going to graph this function using intercepts where 3x plus 4y equals 24. Here we go. Let's find our x-intercept, knowing that all we have to do is cover up our y term, because if I'm solving for x, then I don't need the y. And then from there, we are going to rewrite our tiny equation. And then if necessary, which we know it is because there is a coefficient in front of the x, solve it by dividing. When we do that, we learn that the x-intercept of our equation is 24 divided by 3, which happens to be at 8. With our x-intercept horizontally placed in the center of our coordinate plane, we place a point on x equaling 8. Awesome. All right, let's finish this up. The y-intercept tells us that we don't need our x term, so I can cover that up or I can mark it out. Afterwards, rewrite your tiny equation of 4y equaling 24, and then if necessary, solve for y, which it is because I have a coefficient in front of that y. So I divide off the 4, canceling it out, so that our y-intercept is found with 24 divided by 4 being at 6. Here on the y-axis, down the center of my coordinate plane, we know that our 6 is located right there, and we can finally bring this problem to a close by connecting our points with our handy-dandy ruler. And there you go.